Well, hi, friends. Welcome to a beautiful sunny afternoon in Northeast Ohio from wherever in the world you might be. Thanks for joining us for this Ask Me Anything session.
Thank you to all of you who submitted questions and for your participation in the Ask Me Anything conversations. I find those to be a lot of fun and hopefully helpful for a lot of people. So the first question that's here is came through from John Rossani. Hi, John. Um, One of my biggest challenges about growing vegetables is spring flea beetles on brassica crops. About 4 to 7 days after they're planted out, I see the first flea beetles. Direct seeded spring brassicas are even trickier because of flea beetle pressure. What is the best source of action to prevent this? Should I be applying foliar application in the greenhouse at the seedling stage? And what seed treatment would help? Would a seed treatment help with the direct seeded crops? John, excellent questions. And the answer to several of your questions is yes. Should you be applying foliar applications in the greenhouse at the seedling stage? Yes, you should. The nutrients that are needed for plants to be resistant to flea beetles specifically are elevated levels of magnesium. Let me see if I can remember this now. Had a bit much going on. Magnesium, sulfur, molybdenum, and particularly boron. Brassicas and cherries have amongst the highest boron requirement of any crop that I know of. And it's common for many growers who've been trying to discover where the boundaries are of improved plant performance with higher boron applications. I know of a number of brassica growers that are pushing boron applications upwards of 4 pounds of actual boron per acre per year over the course of the crop season. And as their rates have gone higher, they've seen increasingly positive benefits. Um, and of course, all of that depends on having adequate calcium in the soil levels as well to support the to avoid causing any boron toxicity symptoms. So, um, in the case of direct planting and direct seeded brassicas, you need to use a seed treatment or an in-furrow application or some way make sure that those seedlings have adequate levels of those elements, particularly boron, immediately right when they emerge, right as they emerge and as they germinate. So hope this helps. And then John also has a follow-up question about growing garlic, trying to form a picture of the critical points of influence for this crop. When would I focus nutrition on the cell division stage? Would the scape be a similar stage to the blossom forming stage of fruiting crops? Does the removal of the scape throw off the auxin and cytokine balance of the crop? Would the swelling be similar to the fruit fill stage? Would it be beneficial to focus on ripening if there is no grain or fruit to ripen? Very good questions again, John. This is a bit of an oversimplification, but in the development of a bulb, and this is true for both onions and garlic, the development of the bulb is essentially a vegetative process, not a reproductive process. So if you want to, unless you specifically want to propagate through scapes and perhaps do breeding work or something like that, then the best outcome for the largest bulb size and firmest bulb size is to focus on those nutrients which drive vegetative growth energy. So when we have large, wide stems, wide leaves rather, we have large, wide leaves, and good cell division, continuous vegetative growth in that bulb, all the way up until within the last week to 2 weeks of maturity. So the elements that we would be sure to provide generous levels of would be particularly calcium, and then later on during the development period and during the bulb fill period, potassium as well, particularly for onions. Question from Dwayne. Is there any evidence of yield drag when using humic substances in the furrow versus in a fertilizer sideband, which is better? Plus rates and different humic qualities for broadacre crops in northern Alberta. Hi, Dwayne. This is a very good question. Generally, humic substances, there's, of course, a lot of variability in humic acid, fulvic acid. Is it potassium hydroxide, alkali extracted? Is it not alkali extracted? There's a lot of variation here. But speaking very broadly, the only possible yield drag effect that I am aware of, and actually it's worth expanding on this a little bit. Let me finish my thought. The only yield drag effect that I'm aware of that humic substances could produce is that they can bind with nitrogen. And in a few instances, I know of growers who dramatically over applied humic substances, or what would be an over application, in my opinion, to the tune of a couple 100 pounds per acre. That was concentrated in the furrow at planting or close proximity to planting, and that resulted in creating a nitrogen deficiency. So that's something to keep an eye out for, and that's the only scenario that I have experience with or that I'm aware of where humic substances can induce a yield drag effect. And the reason for that, the reason the humic substances so seldom cause a yield drag effect is because they amplify the plant's ability for homeostatic balance, and they also provide homeostatic balance within the soil itself. Now, that's a very homeostatic balance is a very important and very key phrase. We don't talk about it enough in the agronomic context. I wrote a blog post about it a couple of years ago. And homeostasis is essentially a fancy phrase for describing the ability of an organism to self-regulate. So, maintaining our body temperature, for example, is a homeostatic process. Our body maintains its own temperature within a fairly narrow range very effectively. It can increase heat production, decrease heat production. And so that is a function of homeostasis, maintaining homeostatic balance. And we do the same thing within a range of boundaries for electrolyte balance, for example. Our bodies maintain a certain sodium to potassium ratio, and our kidneys filter out and flush whatever is in excess supply to maintain a certain electrolyte balance. That's again an expression of homeostasis. Plants have this same ability to a limited degree. Soil microorganisms have this same ability to a limited degree, as do soil clay colloids. But the one material that has this capacity to an exceptional degree is humic substances. And the fascinating part is that not only do humic substances have this capacity for homeostatic nutrient availability regulation, in other words, let's say you have excess of phosphorus in your soil, you can apply humic substances and it will reduce phosphorus availability to the plant. Or let's say you have phosphorus deficient soils, you can add humic substances and it will increase phosphorus availability to the plant. It's a wonderful function, a wonderful capacity to either increase or decrease nutrient availability dependent on what the plant's requirements are and to maintain homeostasis. But the amazing characteristic of humic substances is that not only do they have this capacity in and of themselves, but they actually confer this capacity and increase the capacity of plants and soil microbes, where their own capacity and their own ability for homeostatic nutrient regulation is expressed to an even higher degree. Now, humic substances give them the ability to maintain their nutrients more easily within their desired ranges. Fascinating characteristic and a very important piece for us to be aware of. Then to your second question, Dwayne, will the soil primer be effective if the ground freezes like it does in northern Alberta for at least 4 months plus? The short answer is yes, it will. And what happens when soils freeze or become colder, then all these biological processes slow down. They don't stop, but they slow down. And in our usual or common worldview, we tend to think of slowing down as being a negative. We tend to prize going faster and faster and being bigger and stronger and everything else. But slowing down is actually very valuable when it comes to the decomposition of organic materials in the soil. When you look at what happens in soils closer to the equator versus closer to the North Pole, in terms of humic substance formation, and we start looking at physics, the physics of particles, biophysics. If you were to just consider the various mined humic substances, the farther north you go, Humic substances have a higher concentration of what historically was called humic acid and a lower concentration of what historically was called fulvic acid, which would have lower, theoretically lower molecular weights. The further south you go, the closer to the equator you become, those ratios begin to change. You have much higher concentrations of fulvic acid, much lower concentrations of humic acid. And while there's much debate about those classifications and how these various compounds are described, and their relative merits and use in agriculture, it's been described by several soil physicists that the reason we have higher concentrations, relative concentrations of humic substances, humic acids farther north is because we have colder temperatures during the winter and the reaction speed slows down. As the reaction speed slows down, we get the buildup of these longer, more complex humic substances. And so putting on a rejuvenate application in the fall when we are decomposing organic matter is going to lead to much greater generation of humic substances than when we apply it in the spring. And this is one of the reasons why a fall application is so valuable and has such a much greater effect on building soil organic matter than a spring application does. Question from Ben Seawalk. Hi, Ben. I farm in Saskatchewan growing peas in my rotation. Over the last few years, root rot has become an issue to the extent that in some fields, I can't grow peas anymore. I was told it is a soil disease and the only way to solve it is to wait at least 10 years before seeding peas again and make sure to use fungal seed treatments. I don't use those types of seed treatments. I was wondering if you have had experience with root rot and what you might recommend. Also, I'd like to thank you for your talk with Keith Burns. The idea of growing seed for next year in a diverse set of plant groups to get the best microbiome is something I'm looking forward to experimenting with for my wheat seed. Well, thank you, Ben. So to your question on pea root rot, I'm trying to remember root rot in different diseases that's a common name that's used to describe different organisms, and I'm trying to remember if root rot in peas is Fusarium or something else. What I can say, we do have our consulting team in the Pacific Northwest has worked with root rot in peas, also in the Midwest. So we do have experience. Let me just look this up right now. There's a lot of positives to working with many different crops and many different diseases, but sometimes after a while things become a little bit blurry when you have disease common names that are different, but that have different organisms for different crops. So yeah, we have Fusarium plus Aphanomyces. So I don't believe, let me say it this way. I am persuaded that we can solve root rot in peas with a combination of nutritional and microbial seed treatments, and perhaps also looking at what's going on in the soil. I don't think it needs to take 10 years. Places that I would look or experiments that I would do to see what the possibilities are is I would experiment with BioCoat Gold and well, you're in in Canada. We have a microbial inoculant that I expect would be very successful, but it's in the going through the registration process. I'm not sure exactly how long that will take. It tends to take a while to get through the Canadian registration process, but it is a microbial inoculant called Santerra that I have a high degree of confidence in would be effective for this disease to create a disease suppressive microbiome where it doesn't express itself to the same degree. And also, given the association with these organisms, one of the first places I would look is I would look to evaluate what the absorbed plant nutrient levels are of manganese and zinc. I suspect they're low. Perhaps boron as well. In fact, I would suspect boron to be low as well. So I would look at manganese, zinc, and boron as some of the first places that I would look at to produce resistance to that disease. Question from Mark Tupman. Hi, Mark. I'd like to hear your thoughts on the effectiveness of foliar applied micronized minerals. I have applied micronized minerals in foliar formulations a number of times and followed up with sap tests. I'm yet to see any significant level increases when compared with non-treated controls. Well, in my opinion, there's your answer. And I'll respond to that. However, when we apply soluble nutrients in foliar formulation, we often see increased levels in the sap analysis. Is applying micronized minerals to the foliage a waste of time? In my opinion, um, applying micronized minerals to the foliage is a waste of time unless they are complexed with organic chelation agents and materials that can get them to cross the leaf cuticle and be effectively absorbed by the leaf, and or unless you have a very vigorous and healthy microbiome on the leaf surface. So it's possible to have, we know that we have this healthy microbiome on the leaf surface in what is called the phylloplane or the phyllosphere, very similar to the rhizosphere and the root system. And these organisms they are there. One of their functions, amongst many, is to consume dust particulate matter and to provide nutrition to plants. And so the biology on the leaf surface can consume micronized minerals and make it available to plants, as long as you have enough biology on the leaf surface. Many plants and many crops today don't, unless significant progress has been made on regenerating the soil microbiome or the microbiome is being managed specifically. So we have a number of products in our product lineup are micronized, but they are also complexed to facilitate transportation. And just for what it's worth, sometimes the argument is made that micronized minerals like micronized calcium carbonate and so forth are gain access through the leaf through the stomata. That makes no sense whatsoever. When you start looking at the fraction of the leaf surface that is covered with stomata, it is so infinitesimally small that it makes the absorption of particulate matter through the stomata extremely improbable in any significant amount. So we do get very good sap analysis response from micronized minerals that are complex. And then, of course, we also are often adding microbial inoculants to our foliar applications as well. We tend to think of foliar applications as primarily being for soil or seed applications. Excuse me, I misspoke. We tend to think of microbial inoculants as primarily being for soil, but they are also very valuable for the leaf surface, particularly some of the phytosanitary bacteria if we want to produce disease-resistant microbiomes on the leaf surface and so forth. Question from Jameson Brown. Do you have any thoughts on how nutrition could influence honeybee resistance to Varroa destructor mite? Oh my goodness. You had to ask this question. Yeah, I'm very familiar with the mite. How would you go about determining what nutrients or microbes enhance the bee's immunity to these parasites? And then your next question, what are the nutritional or microbial imbalances that lead to susceptibility to woolly aphids in apples, Johnny Gold variety? Okay, different question, different conversation. So on honeybees, there is already research in the literature describing how having adequate lithium in the diet will essentially make honeybee hemolymph. It's been a while since I read this. Right now, I don't remember if it will actually kill the mites or if it will make the honeybees repulsive to the mites. I don't recall the exact mechanisms or if the mechanisms were even described, but it has been described that having generous lithium levels in adult honeybee populations will dramatically shut down or suppress the Varroa destructor mite. And that led to a bunch of interesting questions for me. What are the heavyweight or high atomic weight elements that are comparable to lithium that have similar biochemistry and what if the research that was being conducted was looking at lithium as a biocontrol, as a treatment, and feeding it in sugar water or feeding it in the water source. But um, what if it's only required? What if it were present all the time in very tiny concentrations, like a few parts per million? I don't know what an appropriate concentration would be for lithium. What are the plants that naturally absorb lithium very well, or what are the geological regions that have elevated lithium levels? And why is it we know that there are some regions of the country, when I say we know, beekeepers know, practical experience. Um, Beekeepers know that they can have honeybees in a certain geographic region that are supposedly resistant to mites. And they have gone through a lot of effort for selecting for mite resistance. And they select mite resistant queens and strains of genetics that have demonstrated very good mite resistance in a local geological environment. And then they transport them hundreds or thousands of miles away. And they crash and burn. They failed to perform in the same way that they did in their original environment. At some point, it's worth asking the question, what is present in that environment? What is showing up in the nectar or in the pollen in that geological environment that is not showing up elsewhere? Um, it's not just the absence of toxins, because some of these environments where honeybees are demonstrating better resistance are environments that are surrounded by mainstream commodity crops and are getting loaded with all kinds of pesticides, neonicotinoids included. So it's not just the absence of pesticides, it is also the presence of something else that is going on in that ecosystem. So I think there's a lot of questions worth pursuing and exploring in that space. And I don't have answers, but I think there's certainly a lot more digging that is worth a lot more research that's worth pursuing. To your second question on nutritional imbalances that lead to woolly aphids in apples, it is the classical magnesium, sulfur, molybdenum, boron. You address those four, and the woolly apple aphids will disappear. So, follow-up question a related question from Travis Johnson. Do we have any experience with grain sorghum midge in the environment that causes them to thrive? Yes, we do. And it's been a while since I looked at this, but if I'm not mistaken, grain sorghum midge shows up in a similar environment or a similar plant nutritional profile as spider mites and thrips, um, particularly spider mites, that is associated with elevated levels of ammonium within the plant and low levels of sugar in the plant sap. If you want to dig deeper, there are specific nutrition recommendations for how to manage that. Please connect with our AEA team, and we can give you specific recommendations for dealing with those. Question from Kenneth. I was wondering how you would address a low base saturation calcium soil. The base saturation is around 30% with low magnesium, acidic pH, high hydrogen and aluminum. We are, for the most part, small grain farmers, and I don't think that liming is quite an economical option. Liquids are an option for us, but is it justifiable to nurse calcium in the furrow, and what type? How much would you recommend? Kenneth, for some reason, this question seems familiar. I don't know if I did actually respond to it in the original webinar or not, but what I would propose is that you band either pelletized limestone or liquid lime, and I would use calcium carbonate. I would be slow to use magnesium carbonate. I would either use a pelletized form or a liquid lime form, and I would band it in the furrow or in strip till. I don't know exactly what your planting setup is, um, but concentrating it in a band in the furrow. And then also, um, you might want to take a look at what types of plants can you bring into your crop rotation. If you are doing wheat and fallow, what if instead of doing fallow, you did a partial cover crop or partial year cover crop with a diversity of plants that is known to bring calcium up and increase calcium availability? And you might also take a look at an application of a soil primer like a rejuvenate and spectrum combination, because we have observed many instances where when biology is supported with these types of applications, either with cover crops and also with rejuvenate, applications where all of a sudden the calcium levels jump from 3 to 500 parts per million to 700 or 1,000 parts per million, or they jump from 1,500 to 2,500. There's these dramatic jumps in calcium supply and calcium availability, even when none was applied. Now, of course, in order for that to happen, requires that the soil have the right base geology in order to get that increased calcium availability. But this is not an uncommon phenomenon. And so I would suggest that the use of banded limestone applications can be very valuable and and produce a very strong ROI, but that you should think of them as an interim tool and see what plants you can use and what biology you can use to build your calcium availability. Then a follow-up question from Ken: how effective is an application of biology in the fall when the soil is dry and no plants are growing? And the answer is it can be very effective. I would prefer to have rainfall within 3 to 4 weeks of application, but I've worked with applications where rainfall didn't occur for 6 to 8 weeks after application, and we still got a very nice soil and plant response following that. Question from Patty. Hi, Patty. How do legume plants or too many legumes in the plant community cause compaction or hard soil? This is an intriguing question, and the answer is they do. We see this in alfalfa fields, you see it in soybean fields. Um, and the brief version, the short version, as I understand it, is that legumes, the nitrogen that legumes fix and make available to the soil microbiome and to the plants and to the crop, uh, results in a much narrower carbon to nitrogen ratio in the soil profile, much the same as if you were to add commercial nitrogen fertilizer. And that narrowed carbon to nitrogen ratio results in the soil biology rapidly cycling much of the microbially active carbon that is available in the A horizon in the top 6 to 8 inches and releasing it as carbon dioxide. So you get a strong flush of carbon dioxide coming from the soil surface, but the effect over a year or over a several year period is the soil becomes very compacted because the A horizon has lost its reserve of microbially active carbon. Question from Rye. Hi, Rye. I grow a companion cover crop with my cash crop that I crimp or the smother after flowering ideally, or before the cash crop begins to flower. When that happens, the cash crop seems to be well supplied in nutrition and can be seen to go up in plant health and heal from an infection if there is one, for example. Is this primarily due to nutrient release from the decomposing plant material, or the decomposing and unemployed microbes the plant grew, or both? The answer is both. You are getting a response, both carbon dioxide response from the decomposing plant material, and you're also getting a response from the microbial nutrient release that is in the root system. Question from Sean. What is the current relevance for application in regenerative practices utilizing Ream's theory of biological ionization? RBTI. I've studied it a lot, and I really respect a lot of the pioneers. Kerry Reams was a pioneer in the biological, ecological agriculture space 60, 70 years ago. Are these methods still useful and applicable for today's regenerative agriculture? So, I would offer a guarded yes or a cautious yes. The reason I would suggest caution, there's a reason why Ream's approach is not more widely utilized today. Two reasons. The first reason is that some of the people who adopted and advocated for their use became very dogmatic and were closed to further development and further innovation. That was one challenge. And the second challenge is that the environment, the ecology, the microbiology of ecosystems has shifted dramatically from Ream's day. And this is true, by the way, not just of Reams, but also of Albrecht. So there's this interesting phenomena where Reams and Albrecht left very thorough documentation of a lot of case studies through the 50s and 60s and into the early 70s, where they described how they were able to put on an application of a ton per acre of soft rock phosphate and 2 tons per acre of limestone and 2 tons per acre of poultry manure and observe this remarkable regeneration where a field or a soil just bloomed and exploded. They got tremendous crop production, dramatic improvements in plant health, and the effect lasted for years afterward. And today, we do not see those types of responses. We don't see the types of responses that they are referring to or that they described. And I know because I've tried those types of applications 15 years ago, repeatedly in many different contexts and settings. We did not see those types of responses. So what has changed and what is different today, or what was different 15 years ago or 10 years ago from 70 years ago? And I think the differences are that our biology has become much more degraded in many soils, but it's hard to prove that because how do you go back in time and measure what existed earlier? And secondly, many of our agricultural soils in particular also have degraded biology and perhaps other things, degraded soil structure as a reflection of chemistry use. So whatever pesticide residues remained in the soil 70 years ago were but a tiny fraction of what is certain to be there today. So it is a combination of those two reasons why I think we've made tremendous advances and tremendous progress in being able to measure and manage the microbiome effectively that we didn't have 70 years ago. And I'm confident that if we had been able to measure the microbiome, then Reams would have been at the forefront of using not just chemistry, but also microbiology to manage nutrition effectively. And that's the direction that we need to go in the future. Actually, I should clarify. One important, I just misrepresented Reams there a little bit when I said he would have used microbiology instead of exclusively chemistry. The reality is Reams wasn't using chemistry. He was using biophysics. He used chemistry terms. He appropriated chemistry terms to describe what he was observing from a biophysics perspective. But his biophysics perspective was very valuable and is still useful today for the people who can parse it and interpret it and understand it. Question from Johannes. Can heavy clay soils be restored? Can carbon be sequestered via foliar amendment applications guided by sap and soil analysis, soil reinoculation with microbes, intense animal impact and rest? Or will I need to be applying larger amounts of calcium, phosphorus, potassium, etc. to balance my soils? I had my soils tested through Albrecht, the Kinsey lab in the US, and the advice given cost me over $4,000 per hectare, which is not possible at the moment. So the answer to your question, Johannes, is yes. It's not an unqualified yes. There are a few qualifications, but generally the answer is yes. When you work with foliar applications, you do soil reinoculation, intense animal impact, all the things that you described, yes, you can. The plants and biology have the capacity to balance your soils within some constraints, within some boundaries. And those boundaries are what are the minerals and the nutrients that are present in your geological parent material that they can extract and make available. Some regions, for example, no matter how good biology you have or how good your management of your ecosystem is, and with your foliar applications, etc., you will never succeed in greatly increasing, let's say, selenium levels, for example, or molybdenum levels or iodine levels, simply because they are not present in the parent bedrock material. Now, those areas and regions of the world are surprisingly small for many nutrients. Many nutrients are present even in tiny quantities. And it's also worth mentioning that for many of these nutrients, the effective amounts of molybdenum or cobalt or selenium can be measured in grams per acre. So it can be very cost effective to apply small amounts of these minerals as foliar applications, and they will produce a disproportionate crop response and soil response from their application.
There was one question that was sent to me directly by one of our growers in advance, um, who asked about a fall application of the soil primer, given his context is in Southern California, and given a high temperature environment, his question was that they might have an Indian summer with 100+ degree temperatures, very high air temperatures, which would also correspond to higher soil temperatures. And would it be better to wait to apply the soil primer application until the soil had cooled off, or could he apply it right at the beginning? And thank you. The answer is that earlier is usually better, particularly if the trees are no longer, if their photosynthesis has slowed down and they're not sending as many sugars out through the root exudates anymore. And the benefit of the soil primer application, and the reason for putting it on in the fall, is because we get a lot of cumulative nutrient release during the dormant period. So when we have really active biology during the dormant period, the availability of nutrients builds and builds. And this is one of the reasons, one of the foundational aspects of why we get this rapid flush of growth in the spring. It is plant physiology has evolved this way as an adaptation to this flush of available nutrients. So that's one of the key pieces to keep in mind. It's one of the reasons why a fall application of primer is so effective, is because we get this continued dormant season accumulation, which has a very big payoff, the following spring. Because if you measure the soil bioavailable nutrients using a Haney analysis or other types of soil analysis, we often see some very significant improvements in bioavailable nutrients from a fall application of soil primer. And just like that, we've got 16 questions in the Q&A. Wow, thank you all. Thanks for attending and for being here. All right, so going to dive into this 17 questions in the first 3 minutes. I always say that I make an attempt to keep my answers concise and to keep moving, but everyone, and the feedback that I get from these sessions, everyone tells me that the thoroughness of the answers and the explanation for why is also very much appreciated. So constantly trying to balance those two. First question is here from Timothy Robb. Hi, Timothy. Nitrogen struggles to get into my lettuce crops, as confirmed by low total nitrogen on sap test. I've experimented with many forms of organic approved nitrogen, fish hydrolysate, corn steep liquor, aminos, macropac, but observed very little crop response. When I use urea, I observe tremendous crop response, darker leaves, faster growth, higher bricks. Why might these organic approved forms of nitrogen not be affecting my plants like urea, especially considering they're supposed to be healthier, more energy efficient forms of N? That's an interesting question, Timothy. I don't know the answer to the context and everything that's going on in your operation. The first question that I would ask is, what are your chloride levels? And the reason for asking that question is because when you have high chloride levels, along with other anions, it's not just, nitrate, or I shouldn't confine this to nitrate, but nitrogen in its various forms is strongly suppressed. The absorption of nitrogen in its various forms is strongly suppressed by the presence of high concentrations of other electrolytes and high concentrations of other anions. So electrolytes plus anions. So your electrolytes are going to be magnesium, potassium, sodium, chloride, and nitrogen. Of course, we're trying to get nitrogen. So high levels of the other electrolytes can suppress the absorption of nitrogen in its various forms. High levels, so chloride fits into that category as an electrolyte. But then also high levels of the other negatively charged ions, like sulfur, phosphorus can also suppress nitrogen absorption, except that urea has such a high solubility, also has a very high salt index, and by itself is also a very strong electrolyte, that urea is strong enough to overcome these hurdles that the other organic nitrogen forms may not be able to overcome. So the moment you say that if you're describing a scenario where urea is being absorbed but other forms of nitrogen are not, my first guess, and this is just a guess, is that your other anions or your other electrolytes or a combination of both, possibly in the form of chloride, might be excessive, which might be limiting the nitrogen absorption. So that's my best guess. That's the first place that I would start looking. Question for David King. Looking for recommendations to study the management of vegetative and regenerative energy in plants. My Native American clients understand the concept of balancing masculine and feminine energy. Educated farmers understand auxins and cytokinins. Biodynamic farmers understand earth energy and cosmic energy. My concern is that all of my work is being performed from observations. I would like some science to back it up and expand my understanding. I recall you broached the subject in regards to California strawberries and ion management. Do you have any recommendations of where I could further my study and understanding of this subject? David, this is a fascinating question. And first of all, there's nothing wrong with observational experience. And I know that the reality is that you can dig deeply into this topic from a scientific perspective. However, it is very challenging and dry scientific academic reading, and it is challenging to even translate that information into a context that is accessible to growers. And so the research that you're looking for, if you want to look at this from a scientific perspective, you would primarily look at it from the perspective of hormonal phytohormone balance, so auxins, cytokinins, and so forth, and review the literature that associates all these various mineral interactions and microbiome interactions with these various hormones. I would also point you to the work of Jerry Stoller. Not a lot of work of his has been published, but some of it is out there from Stoller Enterprises. And those would be some possible resources, but don't discount your observational experience, because the key is each individual variety. When you look at, we can't just talk about wheat, because there are significant differences between tall grass and short grass wheat varieties, or tall stem and short stem, I should say. And we know that apple trees have very widely degrees of vigor. So we have to tailor our experience and our observations to specific varieties, to specific cultivars. And that is why, even when you have the strong scientific backing in this, you still have to adapt it based on experience with the exact plant species and variety that you're talking about. Question from Felipe, depending on my sap analysis sample, how often should I apply foliars to my pear trees previous and after harvest? Besides sap, any suggestions to avoid fungal diseases on pears during flowering and young fruit growth in a rainy and humid area? So the answer to your first question is, how often should you foliar spray? As often as necessary and as often as practical to maintain nutritional balance. And the interesting part of that question is that the healthier your trees become, the fewer applications are required. So we find that when your trees become really healthy, less frequent applications of smaller amounts of product produce longer and longer term effects, until ultimately you get to the point where you need very minimal applications, or perhaps even none at all in an ideal scenario. And and early on, during an early transition period, if you have severe nutritional imbalances, then they may require more frequent applications, to the point of as often as is practical. To the second part of your question, any suggestions to avoid fungal diseases? So The it's I have a desire to oversimplify here, and I have to be cautious. Again, we have to address the foundational macronutrients, particularly calcium and phosphorus. Make sure we don't have excessive levels of nitrogen and potassium. And but I would suggest that the majority of nutritional imbalances that are associated with disease are a result of trace mineral imbalances, particularly zinc, manganese, copper, cobalt, and boron. Iron is also involved, but less. We see that showing up less frequently, corresponding or associated with disease. So um, I'd make sure you have to address the foundational macros like calcium and phosphorus, and silicon is also worth mentioning, but then really pay attention to those trace mineral, particularly the metallic trace minerals. Question from John Pierce. Hi, John. What ingredients do you recommend for root dips? What with a pH range and the EC part per million range? John, this is a great question. So for root dips, historically, we have generally used rejuvenate and C-stem, occasionally humicarb for specific challenges with very saline soils. And then also, if it's possible, if it's appropriate in a certain area, and if it's approved from a regulatory perspective, I would suggest Santerra and BioCode Gold. And if we're not able to use Santerra, then I would probably use either Spectrum or OP8, depending on the context. The pH, and so when you think about that, I deliberately did not include Sea Shield in that recommendation because if we're putting together a relatively concentrated root dip, then Sea Shield can have too acidic a pH because of the sulfuric acid stabilization. And neither the rejuvenate nor the C-stem has a particularly high EC. So those tend to be softer, less harsh materials, if you will. And I don't have a number for you off the top of my head about what the EC range should be. That's an interesting experiment. I would guess it should be sub 6,000, but that's just an educated guess at this point and need to do more homework on that. Question from Francisco. Should we fertilize in seedling production? The answer is yes, but not with potassium and not with nitrogen. And what I mean by that is I'm not suggesting these seedlings require or should have no nitrogen, no potassium, but they should be very minimalized. And the emphasis should be on calcium, magnesium, and phosphorus. And when you do that, you produce a plant that has, as a small seedling, has a remarkably large root system and is very sturdy, has a large diameter stem, doesn't lose moisture very easily. So the biggest mistake that is made in a lot of seedling production is over-fertilizing and providing them with excessive levels of nitrogen and potassium, and that leads to lower quality seedlings. You can get seedlings to grow as rapidly with calcium nutrition as you can with nitrogen nutrition. Question from Joe. When we get good nitrate conversion during the vegetative growth period, but do not get adequate calcium supply to the plant, does vegetative growth suffer overall, assuming good total nitrogen reading on a SAP test? This is for broadacre crops. So question is, what do you mean when you say does vegetative growth suffer? Yes, John, you're looking for me? Your camera just came back on. All right. So you can get the same quantity of growth. So your quantity of growth doesn't suffer, but your quality of growth would suffer with less nitrogen, without adequate calcium supply. So if you take a corn plant, for example, a corn is a very vigorous vegetative plant. Even if you don't have good calcium supply, you'll still get a lot of plant biomass as long as you have adequate nitrogen. But the quality of that plant biomass will suffer. You'll have more disease and insect susceptibility as a result of the lower calcium levels. And corn is a really obvious, kind of an extreme example, but the same concept holds true for many other plants as well. Question from Leland. My question is regarding the work that Olivier Husson is doing with EH and pH homeostasis. The framework is based on the hypothesis that plants function physiologically within a specific internal EH-pH range. And that is correct. They self-regulate that. homeostasis within very tight boundaries within the xylem and the phloem. The xylem and the phloem are very different, have very different EH and pH ranges, but they manage those very tightly. And that, along with microorganisms, they alter EH and pH in the rhizosphere. My question is, if this idea is beyond the hypothesis level yet, and on native rangeland, would we expect enough effects to be measured to measure EH with some type of metering tool? So the question is, yes, this is beyond, the answer to your question is yes, this is beyond the hypothesis level. Like this is something that's well established in physiological functioning of cells and of larger organisms. The challenge with measuring EH with a tool, which isn't, the tool is an ORP meter, which you may have heard of, oxidation reduction potential. The challenge with measuring it with a tool is that ORP or EH fluctuates dramatically with moisture levels and with exposure to oxidation. So if you have soil that's exposed to sunlight, it will show much more oxidation. If you measure soil on one day and you get 2 inches of rain overnight, you come back and measure it again the next day, you'll have very different readings and very different numbers. So the challenge of measuring it with a meter is that the number is wildly variable. It swings back and forth a lot. And I expect what we know at this point, or at least I'm trying to remember where I read this. What I think we know at this point is that when you have high organic matter content soils that have good aggregate stability, you have less variation. You have less up and down swings in healthy ecosystems. Question from Kenneth. Wondering how you would address a low base saturation calcium soil. The base saturation is around 30% with low magnesium, acidic pHs, high hydrogen aluminum, where for the most part, small grain farmers, and I don't think that liming is quite an economical option. Liquids are an option for us, but is it justifiable to nurse calcium in furrow, and what type? How much would you recommend? Second question is, how effective is an application of biology in the fall when the soil is dry and no plants are growing? All right. You asked challenging questions, Kenneth. Sounds like you're in challenging conditions as well. So first, I am right on the threshold of saying that we should no longer measure our soil mineral levels or macronutrient levels on base saturation. We should no longer have conversations around base saturation because base saturation is misleading for very light and for very heavy soils. If you go below 10 CEC or above about 22 or 25 CEC, then the situation changes. So assuming you're within that range of somewhere between 10 and 20 CEC, then, and if you have, with your challenged economics, what I would suggest, and this is, I'm absent, I don't know the context of your planting equipment, whether you're dry or liquid, but I would suggest that you band in the furrow at planting pelletized limestone or liquid limestone, if that is an option, specifically calcium carbonate. Don't use dolomitic limestone. That will be your most economical form of calcium that will help buffer your acidic pHs. It'll help buffer the aluminum availability. And that's likely to give you the greatest and most economic crop response, the greatest ROI. And then to your second question, how effective is an application of biology in the fall when the soil is dry and there are no plants growing? It's an interesting question. For some of our microbial inoculants, when Bruce Tainio originally developed them, his goal was to develop them to be so resilient that you could spray them on bare concrete, leave them exposed to the sun for 30 days, and come back and add moisture, and they would come alive again. That's a harsh environment. So I'm actually, I'm not concerned if the soil is dry, and I'm not concerned if there are no plants growing, as long as there are reasonable expectations for that changing in the course of the next several weeks. So it's perfectly appropriate to apply a primer application or soil biology in the fall onto dry soil if we are waiting for cover crops to germinate or if we expect to have moisture at some point in the next month. But if we apply it dry and then it stays dry for 3 or 4 months and we have limited moisture, even in that context, I've observed some very nice soil improvement responses, but they were dependent on the soil carbon levels. Was there enough carbon to support and sustain that microbial community? And even though it wasn't particularly active, it stayed in a relatively dormant period, phase, had very low levels of activity until you had moisture applied, and then it came alive. So you might, in very dry environments or with limited plants growing, I would suggest that you expect to see a delayed response rather than a more immediate response. Question from Michelle. Every time I use zeolite, the plants react with an extremely strong auxin dominance behavior. Why is this the case if zeolite has such a strong sponge effect for nitrogen and potassium? The reason, Michelle, I suspect, let me be clear, I don't know this for sure. This is just my hypothesis or my theory. Zeolite doesn't actually have a strong sponge effect or absorption effect for nitrogen. It has a strong absorption effect specifically for ammonium. So if the zeolite is binding ammonium and yet providing free movement or facilitating free movement of nitrate, that would explain strong auxin dominance behavior. It could explain it. I don't know for sure if that is what is happening, but that's one possibility that pops into my mind. Question from Terry. In great Midwest soils, do you have anybody that is producing 70 plus bushel soybeans without using fungicides? Terry, I'm sure that we do. I don't have specific examples that come to mind right off the top of my head, but I'm sure we could have conversation with our farm services team and we would be able to find a number of growers for which that would be the case. Question from Dave. Growing silage corn and transition to regenerative agriculture practices. What would be rotation crops? Boy, Dave, I need a lot more information to be able to answer that question for you well. The one thing that I would consider or that I would suggest is, particularly if you're growing silage corn, which with silage corn, you're coming off early enough that you can plant after the corn. But you might also consider, with the development of drone technology, we now, given the right environment, of course, if we get enough rainfall and if everything works just right, we can broadcast cover crop seeds with a drone 3 to 4 weeks before harvest. And if we get rainfall and planting the right species for which that type of application works well, you can actually take the corn off and have a cover crop that has germinated. It won't have grown a whole lot because it'll be in shade, but the seedlings will be 2, 3, 4 inches tall. You take the corn off and it just goes to town. So that's something that I would encourage you to evaluate and to check out, because you can really speed up and increase the amount of photosynthesis that happens on an acre in the fall if you have seedlings that are already established. Question from James. On a previous Ask Me Anything, you stated that slug problems could be addressed by making sure you had enough iron, either in the soil or in the plants. I'm not sure, specifically in plants. You have to get the iron into the plants, which is a challenge in a lot of areas. I have a huge ongoing problem with slugs that has me re-drilling much of the farm here in New Zealand for the last 3 years since I went to a more regenerative farming operation. I have been having to apply much more iron-based slug bait than I would like. We're using Kinsey soil fertilizer and doing sap analysis. We're not showing deficiencies of iron. That's intriguing. You're not even showing deficiencies of iron on sap? As much as I would love this to be a simple solution, as you say, I can't help feeling that there is more to this than you say. Could you please give me a much more detailed answer, such as how much iron we're looking for in our test and what is the best way to achieve this? All right, James, good question. So, the deepest and most thorough answer on slugs, and the most thorough explanation that I've heard is coming from Harriet Mello. So if you go to the Kind Harvest platform at kindharvest.ag, Harriet Mello has an incredible course that she in which she talks about carbon. I think it's titled Carbon Microcycling. And in this course, at one point, she gives a very thorough explanation of why slugs show up and are problematic. And the short version, if I could condense it down, there is a connection to water transpiration, evaporation, and so forth, and what a plant's water metabolism looks like. But from a practical application perspective, I'm still of the persuasion, in spite of your experience, I'm still of the persuasion that addressing adequate levels of iron will solve the problem. And so my first question mark would be, what is the desired value of iron that is being reported on SAP analysis? How was that desired value established? And is that truly the desired value? Does your crop truly have enough iron? And I would suggest again, there's a lot that I don't know about your local setting and your local context, but I don't think it's reasonable to expect to address iron in the soil. I did a previous webinar on this topic. I think you can find it on YouTube, but your soil can have generous, even excessive levels of iron, and the crop still be deficient because the iron is oxidized. And the only way to address that is with foliar applications of a reduced and chelated iron, which is where we use our rebound iron. If you get the right form of iron, just do a simple experiment. Do a foliar application of a couple of spots. Write your name out in the field, or just do a small square. And if you have iron that is reduced and chelated, and your crop needs iron, you will be able to see, well, there's one more caveat. If your crop needs iron and it doesn't have a surplus of nitrogen, because surplus nitrogen can cover up these effects by already having a field that's dark green. If it doesn't have a surplus of nitrogen, in most crops, you can see a dark green up response to an iron application within days after application. It's very rapid. And so the long-term solution is to develop soil biology that can deliver nitrogen to the crop. The short-term solution is to foliar apply nitrogen. And I'm of the persuasion that when the crop has adequate to generous levels of nitrogen, you're going to solve your slug problem. Question from Matt. In fruit production and possibly vegetables, what actions can I take to increase flavonoid production? Are there specific nutrients a grower should focus on? Specific target crops or peaches? Oh, Matt, this is a great question. Yes, there are specific nutrients that are involved, particularly the trace mineral metals, zinc, manganese, copper, cobalt. Yeah, you asked me about flavonoids and not carotenoids. So addressing all of those minerals, magnesium as well. But the big contributing factor, or a significant contributing factor in addition to these mineral elements, is the microbiome. Because the microbiome both in the root system as well as within the plant tissue synthesizes a lot of flavonoids and provides them to plants. So this is not just plant synthesis, but in fact, it may be mostly synthesis from the microbiome. So using high quality microbial inoculants on the leaf surface and in the soil system and making sure you have really good biology established is probably going to have the most significant effect on increasing your flavonoid production, as I understand it. Question from Melissa. I'm a new homesteader in Northeast Texas with hopes of building some type of ag business. I know you typically work with large commercial farms. My question is regarding the pH of our sandy loam soil, which is currently at about 4.5. My NRCS agent said that I must apply a lime regularly. I believe you said that establishing good soil health down to 40 inches will help the soil to hold on to its nutrients and that a diverse mix of forbs is the best way to build that. Do I need to start with an application of ag lime before getting started with a forbs? I've also been vermicomposting. Would applying a slurry have any effect on soil pH? So you ask a lot of questions, Melissa, and the answer, I don't like giving this answer, but it depends. So I'm responding to your last question first. Would applying a slurry of vermicompost have an effect on soil pH? It depends on if your soil has a reserve of nutrients held in the soil mineral matrix that biology can release. So some soils have high calcium and magnesium and potassium levels that are locked up in the soil mineral matrix. And if you were to apply vermicompost, theoretically, you could release some of that and have an effect on pH. That's certainly something we've observed many times. However, if your soil doesn't have that parent geological material, doesn't have that capability, then you can apply all the vermicompost you want, and you're not going to get the response that you're looking for. So the to your second to last question, do you need to start with an application of lime before getting started with forbs? No, you don't. You could start with either of those. But my question would be, are you in a situation where you have to choose? Why not do both of them at the same time? And I'm, of course, there's a lot of context and knowledge that I'm missing, but the way to speed up the ecosystem response to get the fastest ROI and the greatest crop response the most rapidly is to do both the lime application and the forbs at the same time. It's not an either or question. You can do both. Question from Geo. I read in Mineral Nutrition of Higher Plants that cytokinin is known for shoot growth, not root growth, and the opposite is also partially true for auxins. Am I misunderstanding something? What you're misunderstanding, Geo, as I understand it, is that yes, cytokinin does play a role in shoot growth, and yes, auxin does play a role in root growth, but they are the minor hormone in each of those places, in each of those locations. So it is never what I'm attempting to describe in my previous conversations. Shoots are never in shoots. We never have 100% auxins and 0% cytokinins. It's always a blend. It might be 55% auxins and 45% cytokinins. And similarly in the roots. So both are involved. Both are a part of the system as well as other phytohormones. But it is the balance between the two that determines plant expression. And which of those is dominant. So hope that clarifies and helps answer your question.
Hey, John, sorry, I just want to jump in. There were a few questions submitted in advance. I just direct messages them to you. I just didn't want those to get lost.
Okay, great. Thank you. Question from Eugene. What is the best soil silicon fertilizers for blueberries? Diatomaceous earth, basalt powders, etc. Diatomaceous earth is a possibility, but I don't have a lot of data. But the data that I do have, plants don't, let me say this accurately. Plants seem to respond to diatomaceous earth positively, but not with improved silicon absorption, according to our SAP analysis results, which is interesting. So we're getting a nice plant response, but not a silicon response. Basalt can also be useful. Again, we get to see a nice plant response. Sometimes, depending on the source of basalt, we get a silicon response, but not always. The form that is probably the most consistent, but still variable, is calcium silicate, which is wollastonite. And again, the degree of plant response, the degree of calcium absorption varies depending on the line, or depending on the quarry and the source of where the wollastonite came from. Some quarries are much more bioavailable than others when they have different crystalline structure and as well as different particle sizes. So that's the best answer I have for the question. Question from Jake, following up with the soil primer discussion, also in California wine grapes. Do we need to worry about spraying the primer onto dry ground in fall and waiting for rain? I think I've maybe partially answered that question already. It's really a question of timing. I would be fine waiting for several weeks before rain. I would prefer to not wait for 3 months before rain, which I don't think is likely to happen in your context. Question from Gavin. What advice do you have for an aspiring agronomist with no formal ag education? Well, first of all, congratulations. You have the benefit of not having a tremendous amount of wrong information to unlearn. Currently working as a mechanic, is there a formal education or certification you think would be valuable? I've listened to every podcast and watched every webinar so far. When are you going to apply for a job with AEA? Just out of curiosity. Currently working through kind harvest courses and studying webinars in closer detail. Have been trying to connect with local farmers and educators as often as possible. Gavin, the only resource that you haven't mentioned that I think would be very valuable for you would be reading through the recommended reading list that I've put on my blog. You can find it pretty easily by just doing a search for John Kempf recommended reading. And with what you have already, with the work that you've already done, in our podcasts and webinars, if there's any downside to having focused primarily on those, it would be that perhaps we have skipped over some of the more foundational material. We've just focused on some of the more advanced agronomy concepts. We haven't, in most of, if what I can just recall from memory, we haven't gone into details on basic soil science and so forth. So it might be worth digging into some of those concepts a bit more deeply and find some good mentors. And then you also need to have real world experience with crop scouting and so forth. But I think there are many people that would love to have a conversation given the knowledge context that you've developed. Question from India. Is it beneficial to just chop grass and leave it on the soil in between the fruit tree rows in a subtropical climate? It can be. The answer is compared to what? So the benefits will be that you'll be shading your soil and keeping it cool. The downside is that you will be, or possible downside, not necessarily a downside, but a possible downside is that you will be rapidly losing that residue as most of it oxidizes and goes into the atmosphere as CO2. The question is, do you have a green growing crop that can benefit from that CO2 release? And if the answer is yes, then it sounds like this could be a good idea. Question from Jared. Can you extrapolate the application instructions for seed stem to be on a smaller greenhouse garden? Yes, absolutely. Question from Michelle. Insects are attracted by seed without adequate levels of boron. Just for the boron or also because boron helps the translocation of other minerals and nutrients? So Michelle, I don't know if I would say, certainly the answer is broad. Insects are less attracted to seed that has mineral nutritional integrity in general, and boron is one key critical aspect of that, but it is more than just boron. You could have generous levels of boron, but still have, let's say, manganese and zinc deficiencies. And while your seed would likely preserve well in storage, I would expect the seedling to still have insect susceptibility, disease susceptibility as a result of that nutritional imbalance. But to answer your question, boron does help with the translocation of other, particularly of sugars, and to some degree also of other minerals, including particularly calcium, into the seed. And you could say there's perhaps a domino effect where boron improves calcium translocation, which has an effect on improving the translocation of other elements. Question from Jeff. Question about soil application rates. If an acre furrow slice weighs around 2 million pounds and is 3% organic matter, how can rejuvenate at 0.4 pounds an N per acre recommended make any difference? Well, because the quantity of nitrogen that is contained in rejuvenate is completely irrelevant and is making no net contribution to soil. That's not its purpose. That's not what it's designed for. That's where the better question is, if you have an acre of soil and you measure the atmosphere above that acre, you have 78,000 pounds of nitrogen above every acre of soil. So why would you buy any more? The purpose of rejuvenate combined with biological inoculants is to fix some of that 78,000 pounds of nitrogen and make it available to your plant. You shouldn't need to be buying any more. So the purpose of rejuvenate is not to add nitrogen, is to serve as a catalyst for microbial fixation of nitrogen, which should be a lot less expensive for you than buying it. Question from Phil. We grow 3.5 acres of blueberries with no to minimal chemicals. Still struggling with spotted wing. We've been using AE products for 3 years, but are still struggling with spotted wing Drosophila and now leaf rust this year. I think that's what that is supposed to say. Yield is good and taste is good, but we are far from achieving disease and pest resistance. We do 3 SAP tests per season. Should we be doing more testing? Well, the question, Phil, is what do your 3 tests per season show? And also, obviously, from a plant performance response, you're not getting to where you need to be. At 3.5 acres, you have a large enough scale, depending on your marketing and context, but you have a large enough scale that it's economically justifiable to do more. And the berries themselves, it's concerning that you have leaf rust again showing up this year, but the berries themselves are often, and the fruit of a plant is often the very last stage to achieve resistance, but you should have achieved it well before now. So I would suggest doing more intensive SAP analysis, but more importantly, what are you doing with the results from the SAP analysis? What is your frequency of foliar applications? What does your mineral balance look like? I don't know the answer to those questions, but 3 years in, except unless there are extenuating circumstances and extreme environmental challenges with major mineral imbalances from, let's say, very hard irrigation water, high chloride levels, or something like that, barring any exceptional circumstances, you should have achieved spotted wing Drosophila resistance before now. A question from Mr. Anonymous Attendee with a very challenging question. How do we find a soil chemistry lab that can be trusted? We have sent soil samples to different labs with a variety of results. If you want to really complicate your perspective, you'll split a sample and send it to the same lab 3 times and discover that you can get 3 varying results from the same lab. How puzzling is that? It's important for us to understand that soil testing is a very imprecise science. If you look at the lab testing standards, the standards that labs are held to, it varies a little bit, I think, depending on the type of test and the nature of the test that we're talking about and the standard that it's being held to. But if I'm not mistaken, the standards are plus or minus 10%. Well, if you think about plus or minus 10% deviation, that's a total of a 20% deviation. And if you had calcium levels on one test at 2,400 parts per million, another test at 3,000 parts per million, you would think those soils would be radically different, but that's still within the parameters of the acceptable deviation. So soil testing is a valuable tool. We just need to understand that it's not a perfect tool. It's an imprecise tool, and we need to manage with that context in mind. A shift from 2,400 parts per million to 2,800 parts per million in calcium availability is actually not that significant unless we've replicated it across 3 or 4, half a dozen samples, and we know we have replicated data. Single sample data by itself requires room for variability. Another question on a career in regenerative ag. Should they follow the traditional university route? Which universities would I recommend? Or should they consider starting their own venture? I get asked this question so often I should get advice from people who actually have experience and perspective on the academic system and perhaps publish a blog post or write about this a little bit because this is a common recurring question. What I would propose is that there are some specific educational tracks, as I understand it, that actually offer valuable insights and perspectives, but they're usually not agronomy related. They are kind of agronomy adjacent. They might be particularly agroecology. A number of people that I really appreciate and respect have backgrounds in agroecology degrees, horticulture, entomology, and so forth. But you want to evaluate, I think, to what degree the information being presented in the course is aligned with contemporary agricultural practices. And I think agroecology, from what little I can tell and what little I've observed, seems to be a pathway to learning a lot about agricultural ecosystems that hasn't been captured by contemporary ag. Question from Tom. I'm wondering if oregonite can really boost yields and plant health. I think of oregonite only as a form of relatively high quality calcium carbonate. And so the question is, does your soil in your context require calcium carbonate? And would it benefit from that? And perhaps so in small amounts. But there are a surprising large number of cases where a small amount of calcium carbonate is valuable and beneficial. But it's really a question of, is that the greatest crop response that you can produce for the amount of money that you're spending? And in a lot of cases, the answer is yes, because it's relatively inexpensive. But there's also a lot of cases for which that isn't true. So we need more information. Question from Casey. Can you manipulate a plant's root exudates based off of what you foliar feed the plant in season? Yes, absolutely, without question and significantly. Specifically expressing different amino acids or organic acids than what the species typically expresses. So I don't know about that part of that second question, Casey, based on how you framed it and defined it. But we know that as plant health changes, as microbiome integrity changes, the plant both produces very different carbohydrate and amino acid profiles and organic acid profiles, and also has a very different root profile exudate. And when I say very different, I should add a qualifier in that on a lab report, if you were to measure the amino acid profile, it might appear that maybe, I don't know, I'm making up a hypothetical scenario here. Maybe lysine has increased by 5% and tryptophan has reduced by 2% and methionine has increased by 3%. And you look at that and you say, well, there's no significant differences here. Like these differences are not significant. And they're not from your and my perspective, but they are extremely significant from a microbiome perspective. We know that when we're trying to propagate microorganisms in the lab, changes in relative concentration of nutrients in parts per million concentrations can dramatically alter which microorganisms thrive and which fail to survive. And so what appears to be very slight changes in amino acid profiles when measured on a dry matter basis can be very significant changes from a microbiome expression profile. So it's a very important point that is worth highlighting. So yes, foliar applications, I would absolutely expect as plant health improves, photosynthetic efficiency improves, and all the concept of the plant health pyramid, you will get changes in the profile of plant root exudates. Mike Omeg, my goodness, Mike, what an honor to have you here. Thank you for being here. We are struggling to grow big leaves in our cherry orchards without lengthening the internode spacing on our limbs. How can we grow both big leaves and short spacing between the nodes on the shoots? I'm surprised that this is the case, Mike. I would suggest elevating boron and calcium levels higher and perhaps also silicon levels, which is something that we need to develop and to talk about. But my first guess, we know that boron can serve as a growth, it's too strong of a word to say that it can serve as a growth inhibitor, but boron can really serve to inhibit node length, node spacing, and cherries are close to the top of the list of the crops that have the highest boron requirements. They're right up there with brassicas, some research a long time ago. that I read reported that the healthiest cherry crops were produced using with 4 pounds of actual boron per acre per year, and this was done years before sap analysis. This research was conducted, so that's the place where I would start looking. Question from Tucker. Let's say a wine grape vineyard followed an inadequate NPK approach historically and executed an NPK post-harvest fertility plan that did not address microbes, trace minerals, or feed the soil biology. Although bud break and rapid shoot growth relies somewhat on nutritional reserves, how would you approach fertility out of the gate immediately next season to make a significant difference in vegetative and reproductive functions of the vine for that season? Well, Tucker, you know the phrase that every action produces an equal and opposite reaction? I would take that phrase and adapt it to your context and say, for every previous action that was applied, where you want to go in a different direction, if you want to go in a different direction immediately in the short term, like flipping a switch, it will require an equal and opposite antidote or an equal and opposite counterforce. So if, for example, you have a vine and soil that now has, I'm just making up a scenario here, if you have surplus levels of nitrogen, then you will need to counter that with surplus levels of magnesium and sulfur and molybdenum. If you have surplus levels of potassium, you will need to counter that with surplus levels of manganese. And so you're asking me this question in the phrase of how do you get immediate results? You have to provide an equally strong opposing counterforce. If you can take some time to transition over a 6, 8, 12-month period, it'll require a lot less force and be much smoother and easier transition. And for that matter, probably be easier for the plants as well and healthier for them to not have as much conflict going on within themselves. Can't believe that an hour is. I'm still addressing questions that were asked in the first 8 minutes. How is that even possible? All right. Thanks for your patience to everyone, and I will try to keep moving through these. Question from Weston. I'm going to broadcast wheat seed and harrow it in. Would you recommend blending seed flour on the seed? Yes, I absolutely would. Would it be good to blend granular sugar? Not necessarily. I'm not really a fan of sugar on seed, and also I would be concerned about making seed sticky and not having it broadcast quite as well. Question from Mark. What is the critical point of influence for sizing Brussels sprouts? If nutrition is managed adequately during this period of growth, do you recommend topping the plants to produce large firm sprouts, or is this counterproductive? The benefit of topping the plant is that you get a lot of much greater uniformity, and it's not necessarily counterproductive to have the high degree of uniformity from the base of the stem all the way to the top. And you haven't yet reached a lot of critical points of influence in the case of Brussels sprouts because you're still in the vegetative stage at this point. It wouldn't be until the following year. This is a biennial crop, so it wouldn't be until the following year that you get to the point of bud initiation and so forth. Question from Robert. What can I do to improve soil besides moving cattle across it with soil that is mostly sandy and 20 acres of pasture? I need to host a webinar series, or maybe I'll write a series of articles on some of the things that I'm learning about pasture management. But the short version is what I would suggest, Robert, is managing your grazing pressure and your grazing system so that you produce a pasture that is dominant in forbs. And what I mean by dominant in forbs rather than grasses is not that when you look at it visually across the landscape, it appears you have mostly grass because you'll have mostly grass biomass. But if you count the number of plants per square foot, you'll have more forward plants than you have grass plants per square foot. They're just hidden because they have less vegetative biomass. But in that type of ecosystem where you have forb species being dominant, I'm persuaded that that is one of the pathways to regenerating pasture ecosystems very rapidly. Question, are we planning to expand our distribution network? Yes, we are expanding it constantly. If you have any questions about specific regions, please reach out to our team. What do you hear farmers say are the biggest barriers to entry into regenerative soil practices? And what do you think the answers to the barriers are? Well, Jeremy, there are a lot of barriers. All the way, there's a lot of external barriers. I would broadly, yeah, there are a lot of barriers. Some of the barriers are becoming easier every year. Some of them are becoming harder. But, you know, there was a period of time when we had product challenges where our products at AEA were they were very effective when they were applied to plants, but they weren't the easiest products to use. And thanks to our incredible team, our R&D team at AEA, we've made a lot of progress in this over the last 12 months in particular. But at the exact same time, we would have product that we could send to two different growers. And one grower would have a lot of problems with it, and another grower would have no problems with it. And when we had conversations with the second grower, and this has happened several times, like these other growers are having problems with product from this batch. Why are you not having problems? And I still remember this one grower in particular, his response was, well, you figure it out. You figure it out. And there's that mindset that tends to prevail in the farmers that are the innovators in the regenerative agriculture space. Yes, there are barriers. Yes, there are challenges, all kinds of them. And they just figure it out. They go through and figure it out. I think I'll pause my answer to you for the moment on that one, Jeremy. There's a lot more nuanced conversation that could be had, and all of you know what your own challenges are. There's community, social challenges, mental, there's real physical challenges on equipment and technology that's available. There's labor challenges, there's increased management. There are challenges, barriers that are erected by the USDA and crop insurance. The list goes on and on. And yet there's a group of people that just figures it out and moves on. Is there any quantifiable data on the biocidal effects of glyphosate on soil and other biology? Yes, there is a lot of it if you're willing to look. Just go to Google Scholar and do a search for glyphosate challenges on soil. And also, while you're at it, you might be interested in looking up one of the 3 patents on Google, excuse me, not on Google, one of the 3 patents on glyphosate that is held by Monsanto is for glyphosate as an antibiotic. So without question, it is a very potent biocide because it has been patented for precisely that purpose. Question from Daniel. I'd like to tell us in some detail about corn critical points of influence. How are they addressed? I remember you talking about some V stage of the corn plant is determine the number of ears, number of rows, number of kernels, etc. Where can I find this info in more detail? And how is it used regarding foliar management? Daniel, I have talked about this in the past in a couple of webinars. I think we have one webinar that is titled Managing Nutrition at Critical Points of Influence. And we don't talk about corn specifically, but if you want to talk about corn specifically, please reach out to one of our agronomy team and they can describe for you how we put together nutritional protocols for those specific stages. And yeah, that's what I would recommend. Reach out to our team. It's beyond the scope of this conversation for me to go into that level of detail here. Question from Daniel, is there a way to loosen heavy red clay? The answer is yes. Generous levels of calcium, ultimately organic matter. And what that means exactly for your context is, yeah, I need more information to know the answer to that. An agronomist recently expressed concern about using chicken litter in my organic broadacre setting due to the magnesium found in most litter. That's surprising. I thought most layer manure had higher calcium levels. I guess I don't know so much about broader manure, but my question would be, why do we have high magnesium levels? My soil is at 24 to 27% base saturation magnesium with calcium at 65 to 68. Would you recommend staying away from chicken litter? Well, I would first recommend finding out exactly what the magnesium content is of the chicken litter. And if it is high, then you don't need to add more magnesium to this soil unless your CEC is below 10, at which point these percent base saturation numbers need revision or need to be reconsidered. So to your last question, what are the best practices for dealing with high magnesium soils? Part one, kind of the easy answer, is gypsum applications. Part two is changing crop types to having different root systems and building soil organic matter. Those are kind of the three. The gypsum is kind of the short-term answer that will give you a rapid high-value crop response. Question from Meletta, how to treat high bicarbonates in irrigation water and oxidizing effect on soil? Depending on levels, there's a lot of people who are working on treating challenged water conditions. So you need to buffer it out with acids or with a sulfur burner of some type. That could be a whole webinar in and of itself. Question from Daniel. I'd like to ask about the Regenerative Ag Academy. Looking forward to watching the webinars on redox and the foliar design course. So that information is still available, Daniel, but it has all been migrated to Kind Harvest. So if you go to kindharvest.ag, those courses that were on the Regen Ag Academy have all been moved to that location. Question from Anton. Why do your recommendations typically rely heavily on foliar applications of nutrient? Biologically, plant roots are specifically designed for nutrient uptake. Should we not be more focused on soil nutrient availability and the soil microbiome? What peer-reviewed research backs up your conclusions? All right, so first question, why do our recommendations typically rely heavily on foliar applications of nutrients? For the very good reason that they are the applications that, when they're properly designed, produce the greatest economic crop response and the greatest soil regeneration response for the least amount of money input, because we're harnessing the plant's photosynthetic engine. With a well-designed foliar spray, you can increase a crop's photosynthetic rate and increase the quantity of sugars and carbon that they sequester much less expensively, much more efficiently than anything else that you can do. Secondly, the purpose and the intention of foliar applications is as a transition tool. They are there to accelerate the system. They're not necessarily there to be a long-term tool that there is long-term dependency on, but they're there to speed up the process of regeneration in which they are unequaled. There is nothing else that works quite so well as a well-designed foliar application, in my opinion, with the possible exception of inoculants as seed treatments. And to your last question, what peer-reviewed research backs up your conclusions? There is an abundance of peer-reviewed information on the effectiveness of foliar applications. I referenced some of it in some of my blog posts. You can go to my blog at johnkempf.com. There's a lot of information there. Or use Google Scholar. If you're really looking for the information, you'll find it in abundance. There's a lot of it out there. There's one of the recent publications on foliar applications that I really like is by the International Plant Food Institute, which is, I think, located in France. They have a PDF that's available to download, and also you can request a print copy of the book for free as well. And it is an excellent review of the kind of the state of current knowledge and scientific research on foliar application of nutrients. And the book is so awesome that I wrote a blog post about it. It's linked in the blog on my blog as well. Follow-up question. If you're not using AEA products, what generic minerals and biological inoculants would you include in a root tip for vegetable transplants and bare root trees? If you're not using AEA products, then why are we having a conversation? Um, um, partially joking, of course, but also it's impossible for me to make recommendations for generic products because there is such a wide degree of variation that I can't make reasonable, consistent, reliable recommendations. So I sadly have to pass on the answer to that question. Question from Shankar. Hi there. Look forward to seeing you in at the end of this week or maybe next week. I'm not sure. We have built permabed small farm models and systems in India to build soil aggregate structure from 6 inches to 4 inches depth. You mentioned that using forbs of cover crops is a great way. How do I identify them in India? So the type of plant that I'm describing is not a grass and not a legume. And as I understand it broadly, most of the other, you might have some tropical plants that I'm not familiar with, but broadly, many of the other plant species fit into this category that is broadly called forbs or broadleaves. They're not grasses and not legumes and practically everything else as I understand it. Will our consulting services be available in the UK? Yes, they already are. Connect with Kish Johnson. Do you think that using existing bindweed as a native winter cover crop, tarping in the spring, and adding soil primer after would be a viable option for using, treating, and trying to outcompete the bindweed? I've noticed it doesn't die back in the winter. Perhaps working with it instead of against it is the best long-term option for getting rid of it. Jeremy, it depends on your context and your soil, mineral, and microbiome state. What we observe with bindweed is that it tends to go completely haywire and want to take over when your soils have excessive levels of potassium. And then gradually over time, as potassium levels are reduced, it tends to lose its vigor. It's still there, but not nearly as vigorous. So I think the answer would depend on how conducive your soil environment is to bindweed. If it is highly conducive to bindweed, then simply tarping it and following the approach you recommend may not be enough. On the other hand, if it's right on the edge of where the soil has been largely remediated and no longer needs the services of bindweed, then your approach may be very effective. So it's going to depend on how vigorous your bindweed is and why it's there in the first place. Question from Rich. When thinking of bacterial fungal balance, do you see issues with some of these microbes like boron, zinc, magnesium as related to availability of other macros in corn and soybeans? Are there issues there with adding in humic and fulvics, altering pH for availability? How would you address this? Rich, I'm struggling to follow your question here a little bit. Do you see issues with micros like boron, zinc, manganese, or magnesium related to availability of other macros in corn and soybeans? So the way that I would say, I think what you're asking is, yes, the availability of all of these trace minerals influences the plant absorption capacity of other macronutrients. Zinc, for example, is associated with phosphorus absorption. Boron is associated with calcium absorption. Manganese is associated with potassium absorption. And so adding fulvic and humic substances tends to improve mineral availability of trace minerals as well as of these macronutrients. I hope I'm answering the question that you're asking, and if not, then you're welcome to clarify. Question from Rye Carlson. Hi, Rye. I grow a companion cover crop with my cash crop, but I crimp or is smothered after flowering before the cash crop begins to flower. When that happens, the cash crop seems to be well supplied in nutrition and can be seen to go up in plant health and heal from an infection if there is one, for example. Is this primarily due to nutrient release from the decomposing plant material, or the decomposing and unemployed microbes the plants grew, or both? Is this similar to the effect of applying a soil biological primer in a very large food source? Great questions, Ryan. I would suggest that it's probably both and possibly a third factor as well. It may also be due to a flush of carbon dioxide release from the decomposition of the rye biomass. Many crops benefit a great deal from applications of carbon dioxide, as you're describing. And so I would suspect that the carbon dioxide is also a contributing factor. Question from Andy. I run a sheep and beef farm in New Zealand. A lot of farmers are using high analysis fertilizer every year and have to fly it on with a plane. What would you recommend as a foliar spray to move away from high analysis fertilizer? I can't answer that question in the context of a webinar without knowing a whole lot more information. You're obviously producing forages, so you want materials that are going to enhance very strong vegetative growth, but that will be the second priority. The first priority will be increasing photosynthesis. So you'll want to look at foliar materials like magnesium and iron and manganese, most likely, possibly also a touch of nitrogen. Secondly, you'll want to look at vegetative nutrients. So those would be calcium, possibly nitrogen again, depending on the context and the setting. And then that's not even considering, we haven't even talked about the materials that really increase your forage quality and your livestock performance. So you may not get a significant forage quantity or yield response from adding a touch of cobalt or a touch of molybdenum, but you're likely to get a significant livestock response from those applications. And they're very tiny quantities that are required. So there's a lot of further questions I would need to know the answers to before I'd be able to make a specific recommendation. But I would invite you to reach out to our team at AEA, and we'd be happy to dig into that. Question from Sam. Farming on some land that used to have intensive chicken farming, based on soil tests, it appears there is significant arsenic contamination. Is that a result of the arsenic added to chicken feed? I would guess that's probably the case, Sam, although I don't know for sure. What should I do to mitigate, and what should I avoid growing? Parts per million range from 23 to 120. Sam, I don't know where you are in the country, but I vaguely seem to recall reading, this is several years ago, I seem to recall reading that growing a crop of hemp was very effective at remediating arsenic, but I could be mistaken. What you can do is you can go to Google Scholar and do a search for arsenic phytoremediation. The word phyto is for plants. So arsenic phytoremediation is likely to give you a list of plants that you can use to remediate and remove the arsenic from the soil. And that you would, when I say remove, some plants will accumulate it in the plant residue. Other plants seem to have some magical ability with their associated microbiome where the arsenic levels seem to decline in both soil and in plants. And so that's what I would look for. Question from Pranav, an apple grower from India. We have monsoons from the beginning of the harvest season, which leads to uncontrollable fungal infections, alternaria, etc., leaving almost no leaves on the trees. Almost all the farmers are trying to control it through a mix of contact and systemic fungicides. I've been trying to control it by growing mustard as a winter cover crop with 1 to 2 applications of contact fungicides. What would be the best solution to control such an infection? I'm trying to remember alternaria, if I recall correctly, is associated with manganese. But I think the approach that you're taking, it's very valuable to try to grow more diverse cover crops, but you haven't mentioned that you're doing anything for mineral nutrition management. And that's the place where I would begin, is try to make sure you have balanced mineral nutrition with all the trace minerals. Question from Timo. I feel overwhelmed by the amount of chemistry knowledge in your publications. Which topic would you recommend diving into to better understand the biological reactions of and in plants? Timo, you say the biological reactions. I'm I'm kind of assuming you mean the biological reactions in response to chemistry and to nutrient imbalances. In other words, you're referring to, yeah, I think if I'm understanding your question correctly, I would refer you to my recommended reading list. I've categorized that into different categories, and it's a collection of, I don't know, maybe it's less than 100 books, I think, that they're the best out of thousands that I've read. And there are a number of those that I think you would find very valuable. Question from Francisco. If we use fertigation, what is the effect of fertilizing once a week versus every day? It depends on your soil, your context, how much water your plants are utilizing, and so forth. But I've had some interesting experiences where high value fruit and vegetable growers chose to fertigate every day instead of once a week, with anywhere from a 20 to a 30% yield increase, and in some cases higher. So spoon feeding nutrients every day. If it is easy for you to do so with an automated system, you should absolutely do so. Just fertigate every day instead of once a week, and there can be some remarkable crop responses. Follow-up question from Dave Ryan on the silage corn crop rotation crops. What cover crops would be best or optimal? Dave, I would refer you to the team at Green Cover Seed. Keith Burns has assembled a really great team of people who are the cover crop experts. And I also could offer some suggestions, but to do so would require me knowing more information. It's probably beyond the scope of what I'm able to address well in this webinar. Question from Robert. I'm a veggie grower that worked with AEA in Tennessee, but have moved to Australia. I don't know whether to offer my condolences or my congratulations, Robert. Hope you're enjoying your move. What do you recommend to look for when finding a sap analysis company? I'm not able to ship all the way to NovaCrop. There are actually a number of growers in Australia who are shipping all the way to NovaCrop. And when you're evaluating a sap analysis lab, the one key thing to look for is consistency, consistency of reporting. If you send them 5 sets of leaves that are as biological identical as you can make them, coming from the same location or as close to the same location as possible on the exact same plant, how variable are the results? That is the key. We need consistency of sap extraction, consistency of measurement, and so forth. That's the most important metric. Question from Andre. There's an agronomic line of thought that proposes when it comes to influencing soil structure, the cation ratios, namely calcium to magnesium, should be drawn down from the total digested figures as opposed to the commonly accepted melic-3 or ammonium acetate figures. What's your take on that? I don't know, Andre. This is the first time I'm hearing about what you're proposing. It's interesting. It's interesting, but I don't know. It's really, as I understand it, if you look at it from a biochemistry perspective, the reason William Albrecht's work was so foundational and so fundamental was that he was able to identify that it is the ions on the outside of the soil colloid. It's the ions on the soil colloid that really influence flocculation of soil particles, particularly clay particles. So good flocculation, we understand, is an expression of calcium, magnesium, potassium balance on the colloid. Now, we also know that the melic-3 and the ammonium acetate extraction don't measure precisely what is on the colloid. There are closest approximation, as I understand it, but they also will measure calcium content in limestone particles, for example. So I suppose it would depend on the soil makeup, how much sand, silt, clay we have, what does the geological parent material look like. I've not heard the idea that you're proposing before. It doesn't make immediate sense to me on the surface, but I don't know for sure. Something worth digging into. Question from Daniel. Is there a nitrogen regulator like manganese is for potassium? Um, Magnesium is a regulator to a slight degree. So when you have plants that have extremely high levels of magnesium, then those plants don't absorb and don't utilize nitrogen as well. So there is an element of magnesium serving as a regulator for nitrogen. However, because of nitrogen's just very readily available, solubility, and because plants have adapted in nitrogen deprived environments, or they're constantly searching for nitrogen and they take it up so readily, my understanding is that usually the magnesium would have to be considered very generous or even on the excessive side in order to have that effect on nitrogen. It can be a useful tool. Several occasions when we've had, let's say, tree fruit that were susceptible to fire blight, that had high levels of nitrogen because of compost applications or something like that. You can put on a foliar application with a high content of magnesium and reduce the nitrogen content and increase resistance to disease. How do we determine the adequate amount of gypsum to add as a source of calcium in a blueberry program? Do we need to check CEC analysis and current amount of calcium in the soil? What is the sufficient and optimal amount of calcium in the soil in order to have a balance between cations? Thank you, Meletta. That is an awesome question. When we look at calcium in the soil from a part per million perspective, which I suggest that we need to start having these conversations in terms of part per million rather than in percent-based saturation, for the very simple reason that there are minimal thresholds. You need a minimum of 1,000 part per million calcium to grow really healthy plants. And on soil with a CEC of 7 or 8, or maybe even, I forget exactly where the threshold is, somewhere around 10. If you look purely at the CEC and percent-based saturation, 1,000 parts per million would equal something like 80 or 90%. So it appears that you have excessive levels of calcium, but you don't. You have only just enough to grow a really healthy crop at 1,000 parts per million. So we need a minimum of 1,000 parts per million. And then I would suggest looking at calcium to magnesium to potassium ratios. I think the ratios that Albrecht identified are largely correct with some adjustments for various soil types and extremely heavy soils. The ratios are still generally correct, but look at the ratios in terms of part per million ratios instead of percent-based saturation ratios. And that's where we'll produce the highest quality crop responses. Thank you to all of you for sticking with me as I go through these questions. I know some of these were asked a little while ago, so I'm trying to move through them. Question from Ed. We're going through an unusually cold, damp, rainy season close to Mexico City. How do we prevent rust or fungus damage on oats plants? We had this, I had a day-long session with a group of small grains growers recently. We were talking about rust and head rust and fusarium and other diseases. And many of these diseases and molds are mostly a challenge on plants that do not have adequate levels of the trace mineral metals. So again, the foundational stuff has to be addressed, but once the foundational nutrients, the macronutrients are addressed, zinc, manganese, copper, boron, if plants have adequate levels of those 4 elements, zinc, manganese, copper, boron, the percentage of diseases that would be prevented is very large. It's above 60% for sure across most crops. If you addressed zinc, manganese, copper, boron, we would be successful in preventing a lot of diseases, including these fungal diseases and rust. Question from Melissa. Is an endophyte turning pathogenic more likely a product of nutrient imbalance or microbiome imbalance or some other stress factor? Alyssa, the answer is yes. A nut tree crop, the context is a nut tree crop is susceptible to an endophytic disease it is normally resistant to. my first, from a practical management perspective, the easiest piece to manage is nutritional imbalances. And I don't know for sure what endophytic disease you're referring to, but when I think about other infections which are in a plant vascular tissue, like Pierce's disease or crown gall or citrus greening or Gauss's wilt, um, anytime we have a bacterial infection in the plant vascular tissue, whether it's the xylem or the phloem, almost invariably that can be effectively managed with nutrition management. It's true of all of the diseases that I mentioned just a little bit ago, Pierce's disease and citrus greening and others. Question from Gassan. My plant stems have a falling over droopy appearance despite having healthy looking leaves. Context of proper watering. My question would be, you've seen vigorous growth and radical improvement of your soil. My question would be, do they have excessive levels of nitrogen and adequate levels of calcium? Excessive nitrogen can give you weak stems that fall over. That would be the first question that I would ask. Question from Omari. I'm an agronomist from Bermuda. Recently been hired by the government to do extension work with local farmers. I've been inactive in agronomy for a decade, and I've been asked by the director to suggest some training programs and resources to help me get current. Does AEA provide agronomy crop advisor training, or are there any that you would recommend? Yeah, I think I just answered this. I would look at the Kind Harvest platform. There's some really great courses there. And also my recommended reading list. Does AEA work with government extension programs, either as advisors or support to advisors? We have done some limited work and would be open to more in this regard. So, yeah, thank you for the work that you're doing, Amari. Question from Sean. Could you explain the effects of potassium chloride on pasture soils in areas with high rainfall? I think what I'm seeing is the effect of potassium accumulation in pasture soils with the chloride causing leaching of other cations. Yes, it can do that. Whoop, oh, there we go, just bounced around. These soils have high Morgan extraction potassium levels, 150 part per million. How would calcium application affect these pastures? So, Sean, lots of conversations that could be had here. I would suggest that you listen to my podcast interview with, I'm blanking out, Richard, Dick Mulvaney, and read his papers on the potassium paradox. I've written about it some on my blog as well. The short version is that potassium chloride very seldom produces a plant yield response. And if it does, it's often due to the electrolyte effect, not due to the potassium response. And if I was trying to produce a high quality yield response in forages, I would use gypsum to do that. I would use calcium sulfate and not potassium chloride. You'll produce a similar or better growth response and higher quality at the same time. Roz Kempe has a question about using homemade worm castings. Is this something you recommend? Sure, absolutely. And the reason I don't talk about worm castings is because many people don't have access to them, and certainly not on a commercial scale. In your career, did you have a chance to work on eliminating the flavescence doré disease caused by phytoplasm bacteria in grapes? I would have to look that. I wonder if that's Pierce's disease. I'm not sure. Can you share some advice on plant micronutrients or any nutrition or any foliar treatment for mitigating that disease? So this is perhaps a question for us to have a follow-up conversation with, or for you to connect with the AEA team on. But in short, whenever you have bacterial infections. I'm assuming this is a bacterial infection. Yes, you did say phytoplasma bacteria. When you have bacterial infections in the xylem or in the phloem, it is a function of not having a proper carbohydrate balance, which is a function in many cases of not having enough molybdenum, manganese. Let me say it this way, just for simplicity's sake. You're in Europe. Send leaf samples to Nova Crop Control and balance the mineral levels according to sap analysis desired values. And I would be amazed if the disease did not disappear. That's been our experience with these types of diseases. And also, yeah, we have developed our own desired values of nutrients specifically for disease resistance. So they might be slightly different from Nova Crop Control, but make sure you have adequate to generous levels of trace minerals, and I would expect to see the disease fade away. Question from Oliver, do you have any special recommendations for compacted soil? Yes, I only have one recommendation. Figure out how to decompact it, whether that's with plant root systems or with using steel machinery, whatever it takes. Are there any products or practices that help mitigate salt stress on crops? Soil tests are minimum 300 pounds of sodium per acre. Ouch. As high as 1,000 pounds of sodium per acre. Ouch. And well water tests high on salt and bicarbonates. Trying to use as much surface water as possible, but still tests high on sodium. Well, I would start asking the question, why are you irrigating there? And why are you irrigating with that water? And what crops can you grow that require less irrigation? What about pistachios? What about agave? What about other types of desert environment plants? Because continuing to irrigate with high salt and high bicarbonate water carries the certainty of turning that soil into an even more alkali desert than what it currently is. That doesn't seem to be a sustainable long-term solution. So there are materials that you can add, and I forget what they are right now, but there are specific acids that you can add, things that you can add to your soil to leach your sodium out of the A horizon further down into the soil profile, but that doesn't fix the problem. In the long term, it makes the problem worse. The long term might be 20 years or 30 years or 50 years. In the long term, it just you get continued sodium accumulation. What is the best strategy to help crops in northern climates, 4 months without frost, to help maximize our early plant growth and photosynthesis in high luminosity months, May, June? Seed gets in the ground in cold soil, lots of sunlight early on. Crops always seem to die of disease before the black layer every year, even though the killing frost dates are getting later. Plants give up in late August when days get shorter and dew is staying in the canopy for a longer time. The question is, why are your plants dying of disease earlier? That's the question that we need to ask, and that's the question we need to answer. I would suspect it's a nutritional imbalance of some type, perhaps low manganese. Be one of the things that I would keep in mind, but probably low trace minerals generally. And yeah, we can answer that question with sap analysis. Question from Nikki. I'm a farmer conducting a Southern SARE study on the microbiome of compost tea. I am comparing different brews of aerated compost tea and what microbes are amplified after 6 and 12 hours given different single and combination feeds, humic acids, kelp, molasses, fish hydrolysate, and alfalfa. I have found that there is greatest diversity of microbiomes in the beginning, of microbes in the beginning. Yep, that would be what I would have expected. And as time goes by, only about 3 main families survive and are amplified. All the other bacterial families die off. My question is, why does it do this? What are we brewing this compost tea for? Yeah, Nikki, you ask really good questions. You are selecting for microbes that thrive in that particular environment. And you're selecting for microbes that also thrived in your compost environment. And so the intersection of those two is narrowing it down to 3 families. And your last question, what are we brewing this compost tea for, is an outstanding question. Like what benefit do we need the crop to have? And is this compost tea really the best fit and the best purpose for that? I love the question, love the research that you're doing. It's an outstanding project. And it's quite exciting that we now have tools available like DNA sequencing to be able to measure and understand exactly what's going on. So this is you're doing really great work. I'm quite excited. The question that I would ask, and I don't know the answer off the top of my head, is what are the instances in a crop life cycle where application of those particular groups of family, or those particular families, those particular microbes can be particularly helpful? Is it when they're exposed to a specific disease? Is it in particularly challenged soil environments? So this is the opportunity as we have these, we don't understand very much about the role of families generally, and of individual species most certainly in the soil profile and in the plants. And we know that I think we know that many of these families and organisms have very beneficial effects when they are most needed. And at other times we apply them and we get very minimal crop responses. And that's because they're not most needed right at that moment in time. It's the best answer that I have for you, but I would love to connect with you further, and I'm sure that Laura Kavanaugh would geek out and would love to have a conversation with you about the project you're working on. Question from Christian. In vegetable market gardens, it has become somewhat of a norm to use large amounts of compost, often several centimeters every year. Yes, I know, you're exactly right. And it's a really unhealthy practice and one that I think we're on the threshold of beginning to change. The results seem to be quite good. Do you think that the inevitable mineral imbalances from using those amounts of compost can prevent growers from getting excellent results in terms of plant health and resistant to disease and insects? Yes, I definitely think that. Or do you think biology can overcome even the most severe imbalances? Biology is very powerful and can be very beneficial. However, many of these market gardeners experience severe insect pressure and severe disease pressure, but particularly in the case of insect pressure, it is common to use insect netting to prevent insects from consuming salad greens and brassicas and cucurbit crops. And that is a direct reflection of the excessive levels of nitrogen and the excessive levels of potassium that are resulting from these compost applications. How do you deal with a heavy clay soil with high calcium levels and low magnesium levels? How do we lower calcium levels without allowing magnesium levels to increase when lowering the calcium levels? All right, your questions raise a lot more questions than they do answers. If you have a heavy clay soil with high calcium levels, why do you want to lower the calcium levels? Do you have good soil aggregation right now? Do you want to improve soil aggregation? Have you tested to see what happens when you add even more calcium? And yeah, there's a lot of interesting conundrums there with what you're asking. And this, I don't have time to go into the intricacies of soil testing, but this would be a question, this would be a case. The case you're describing is one where, and again, I'm making these comments without knowing a lot of, I don't know the context, but it would be a case of observe plants and soil and evaluate the tests. And if the two don't agree, you throw the soil tests away and you pay attention to the plants. I suspect that your high calcium levels, my first question would be, do you have a calcareous-based soil? Do you have a limestone-based soil? Is there a chance that you have free limestone particles in your soil profile that are showing up on the soil analysis. So the soil test measures them and says you have high calcium, but you in fact don't have high calcium on the clay colloid. That'd be my first question. That's a fairly common scenario. And those soils and those crops actually benefit from additions of further calcium. And also, when you have a really good microbiome, that microbiome will begin consuming those free limestone particles in the soil profile. And what will happen is your calcium levels, as measured on a on a soil analysis, will actually drop, but your crop performance will actually increase because you have better calcium availability as a result of a functional microbiome. And you also have better calcium on the clay colloid. Are there ways of getting the formaldehyde out of liquid fish? Well, formaldehyde, I'm trying to think. If for some reason I'm thinking formaldehyde is fairly volatile, but I don't know that that's true. I don't have an answer for you off the top of my head, Kevin. I don't know. Question from Cody. Can all AEA products be applied through a pivot if mixed correctly? The answer is yes, although they do produce, we have a track record of some nice crop responses, but just my instinct is we get a better crop response when we fly it on or foliar apply it rather than through a pivot. But we do have a lot of folks who are doing pivot applications. Which AEA products would you suggest for fall foliar application to small grains and alfalfa? As you're going into dormancy, I would particularly suggest boron, but I would ask that you touch base with our AEA team for more specific recommendations. We'd be happy to have a conversation with you on that. Question from Francisca. What is your opinion in using tensiometers or TDR for measuring water use? I don't have an opinion. Don't have enough experience with them to have a direct opinion. All right, I think that wraps up all the questions. There were 100 questions altogether for this session. Thank you to all of you who participated, who contributed questions. I enjoy these sessions. I hope you do as well. And I look forward to seeing you in the next one. Have an awesome day and happy growing. Thank you all.